Hi friends, now let us discuss about CNC. CNC, computerized numerical control, is an automation of machine tool by using computers executing programmed sequences of machine control commands. There are two types of coordinate systems in machine. First one is Cartesian coordinate system. It is also known as rectangular coordinate system. And the second one is polar coordinate system. It is also known as spherical coordinate system. There are two types of dimensioning methods in programming. First one is absolute workpiece dimensioning and the second one is incremental workpiece dimensioning. Now let us discuss about absolute workpiece dimensioning. When we are programming in absolute, all the coordinates must be considered from the origin 0, 0. That point is called absolute 0. Absolute dimensioning in G chords is defined by G90. At the point P1, P2, P3 and P4, the reference will be the origin point. And next, now let us discuss about incremental workpiece dimensioning. When we are programming in incremental, all the coordinates must be considered from the previous point or coordinate. Reference is changed from point to point. Incremental dimensioning in G codes is defined by G91. For the point P1, the reference will be origin. For the point P2, the reference will be P1. For the point P3, the reference will be P2. Likewise, for the point P4, the reference will be P3. Now let us discuss about turning machine controller. Let us have a look at turning machine controller. This is the Siemens controller. We are using 8 to 8D software. Firstly, we have to delete all the existing machines. Select the existing machine and we can delete from here, or else go to file and we can delete from there. Okay, yes, delete the machine. Now let's create a new machine. We can create from there or else create a new machine from here. What we have to create is 8 to 8D basic lathe with driven tool. Select that machine. Next, finish. The machine is being created. Now let's start the machine. We can start from here or go to machine, start. And the created machine is being started. This is the panel processing unit. Panel processing unit is divided into three parts: human machine interface, program control unit and machine control unit. This is the human machine interface and that is the program control unit. This is the machine control unit, and these keys are used to control the program, and these keys are used to control the machine. Now let us discuss about human machine interface. It gives the positions of the tool and workpiece. Here are the positions in Z and X axis of the workpiece, and here we can see the spindle speeds and feeds of tool. If we increase the speed and feed of the tool, it will be mentioned in the human machine interface. Program that has to be operated, and the program that has to be operated will be displayed in the bottom of the human machine interface. Now let us discuss about program control unit modes. Firstly, machine mode. Machine mode. When we get into this mode, it shows the mode that we have selected in HMI. We have selected Mda mode, so it will be displayed in the HMI. We have selected jog mode. It has been displayed at the top of the HMI. Now program edit mode. We can directly open or edit the recently opened file. We have created a new machine, so there will be no existing file or already edited file. Tool and work offset. This is used to select a tool or create and edit the tool in the tool and work offset mode. So now let us edit the roughing tool. Length in x-axis is given 55. Let's change it to 100. We can edit the length in x-axis. Likewise, we can edit. Let's edit the radius. Or else we can create a new tool, roughing tool of third edge position. Okay, and a new tool has been created. Next, program manager mode. We can observe all the existing files and also create the files. Program manager modes. Power program, subprogram, workpieces. In the power programs already there is a file existing. In the subprograms and workpieces. Likewise, in the program manager, all the files available will be displayed. In the workpieces, there are 5 examples. All the files will be displayed in the program manager mode. Next, alarm mode. It gives the information of the errors which are made in the programming. And the errors made during programming will be displayed here. Get back to machine. Now let us discuss about machine control unit. This is the machine control unit. First, reference mode. The primary thing that we have to do is make the machine to reference. Jog mode. In this mode, we use the axis traversing keys to move the machine axis manually. Jog mode. It is used during machining process. Used to move the both x and z axis manually. Mda mode. Mda means manual data analysis. It is used to write the program in blockwise. Let's get into Mda mode. Let's write something. G75 X0 Z0 and cycle start. Both the axis moves to 0, 0 position. Auto mode. In this mode we run the program in full sequence. Generally this mode is used during simulation. Reset mode. It is used to stop processing of current program and to clear up all the errors. It has to be activated during editing of the program. This is also used during programming. If we click on the reset, all the errors represented on the HMI will be erased off. Rapid mode. It is used to move the axis in faster rate in jog mode. This is used during machine rapid mode, and the axis moves very rapidly. You can observe here. Next, single block mode. In this mode, we run the whole program in block by block. Click on the single block. This is used during program simulation to run the program in block by block. Cycle stop. It is used to stop the program that has to be run. Cycle stop is used to stop the programming during simulation. Cycle start. It is used to operate or start the program. Now let's discuss about fundamentals of CNC turning programming. These are very important. An explanation of letters in CNC programming. D means tool offset number D. F, feed as per G94 or G95F. And G, preparatory function G. Diameter input. If we use diamond, the input will be in diameter. If we use of the dimension will be in radius. I, interpolation parameter related to x-axis. J, interpolation parameter related to y-axis. And K, interpolation parameter related to z-axis. And block number of auxiliary block. CR, radius of circular interpolation. It is used during G02 or G03 is given. AR, aperture angle for circular interpolation. P, number of subroutine cycle repeats. S, spindle speed. S100, S200 likewise. T, tool number. X in x-axis and y in y-axis and z in z-axis. Now let us discuss about preparatory G codes. And these G codes resets the tool axis change. G00, linear interpolation at rapid traverse. And G01, linear interpolation at slow feed motion. G02, linear interpolation in clockwise direction. G03, linear interpolation in anti-clockwise direction. G04, dwell time. This is given in between cycle to cycle. G17 is used to select XY plane. G18 is used for ZX plane selection. And G19 YZ plane selection. G40, tool radius compensation cancel. G41, tool radius compensation left side. G42, tool radius compensation right side. G54 to 59, settable work part to 0. G75, use it to return to reference point, homing position. G64, continuous path. G70, programming inch data input. G71, programming data input. G90, absolute dimensions. G91, incremental dimensions. G94, feed in per minute used in milling. And G95, feed in per spindle revolution used in turning. G96, constant cutting speed on. And G97, constant cutting speed off. These are the G codes. Now let us discuss miscellaneous functions M codes. These codes control the machine. M0 program stop, M01 program optional stop, and this is used in between cycle to cycle. And M03 spindle in clockwise direction, and M04 spindle in counterclockwise direction. M05 is used to stop the spindle. M06 tool change at home position, and M08 coolant on, M09 coolant off, M16 tool change at any position, M17 subprogram M30 main program and reset.